you're doing well and welcome to the platform of. So today we'll be solving the problem D triangle count. The difficulty level for this particular problem is simple and the prerequisites required are just basic observation and simple mathematics. So this is your educator Ansh and I hope you like my video. So let's move on to the problem statement. Okay, now it is my humble request to all of you to kindly read the problem statement once carefully before moving on to the solution. Now let me just summarize the entire problem statement for you all. So in the question we are given two integers my L and K. So my L is nothing but the length of the equilateral triangle. So in this particular cases my length is nothing but 4. So as you can see I have my 1, 2, 3 and 4 length equilateral triangle. Now the question has told that we are given L minus 1 points. As you can see, I have in this case my 3 minus 1 which is, sorry, my 4 minus 1 which is 3 points. So here it is 3 points on each side of the equilateral triangle and then they are joined accordingly to form a lot more equilateral triangles, right? So now in the question we are told that we are given integer k in order to find valid equilateral triangles of length k. So basically what is a valid triangle? So basically according to the question, a standing equilateral triangle is a valid triangle and a sleeping equilateral triangle is an invalid triangle. So we have to count the standing equilateral triangles of length k. So if I can make you observe, consider my L is equals to 4 and my k also equals to 4. As you can see, my this particular equilateral triangle is of 4 length and it is my standing equilateral triangle. So the answer for my this particular case is one equilateral triangle and that is my original triangle. Now consider my L is 4 and my k equals to 3. So that means I have to find how many equilateral triangles, standing equilateral triangles are present of length 3. So let me just make you observe that these are the equilateral triangle of length 3. So it is 1 and then I have here one equilateral triangle of length 3 and here also I have one equilateral triangle of length 3. So that makes me 1 on the top layer and 2 on the bottom layer. That makes me total 3 equilateral triangles. Similarly, for my this particular case, say I have my L equals to 4 and I have my K as 2. So how many equilateral triangles of length 2? So just observe this. I have one here, then I have two here, and then I have 3 here. So 1 on the upper layer, 2 on the middle layer and 3 on the bottom layer. So how many triangles? 1 plus 2 plus 3. Here I had 1, here I had 1 plus 2. Third layer I had 1 plus 2 plus 3. Can you all start to think of a pattern that is emerging? Well, if not, then let's see the final test case. So here I have my L as 4 and I have my K as 1. So how many triangles of one length? So here 1, here 2, here we have 3 and here we have 4. So it is nothing but 1 plus 2 plus 3 plus 4. So at any particular instance of time, we can just directly generate or we can see the pattern that for my any particular configuration, my answer is nothing but we obtain the number k, I obtain the number L minus k plus 1 and then in particular this case, it's my 4 minus 4 plus 1 which is nothing but 1. Similarly, here it turns out to be 2, here it turns out to be 3, and here it turns out to be 4. And my answer is nothing but sum of first now 1 natural numbers. For this case, the answer is sum of first 2 natural numbers. Here my answer is sum of first 3 natural numbers, and here it is sum of first 4 natural numbers, which is nothing but n into n plus 1 by 2. So for any particular case, say for this case, the answer is the number of equilateral triangles are 4 into 4 plus 1 by 2, which is nothing but 2 and 5 which are 10. So as you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 equilateral triangles and those are my answer. Now firstly, one more thing, if my k was greater than L, then obviously there are 0 triangles because how can I generate a triangle which is greater than the original triangle? So that is not possible. And that can be treated as a separate edge case and the answer for that particular case is 0 triangles. So yes, this is the approach for the following question and now let us see how to code this particular approach. Okay, now let us have a look at the code for the following problem. So as you can see, we declare the important libraries above. Then for t test cases, we input our both the variables l and k. Now as you can see, as we discussed in a particular case, we just simply compute the value of l minus k plus 1 as we discussed in the approach section, and then if it was greater than my l, which is greater than 0, then we just print our particular answer, which is nothing but n into n plus 1 by 2 for that particular value. So in this case here it is l into l plus 1 by 2. Otherwise, if it is not, then you print 0, because if the length is greater than the original one, then no triangle can be formed. So now let me just run it to the sample test cases to see whether everything is working correctly or not. So as you can see, we got the answer correctly as per the required output format. Now let me submit our code to see whether it is working on the actual test cases. Yeah, so as you can see, we got the correct answer for the following code, and this becomes a correct solution. Now let me also show you the Python implementation for this particular case. So in the following case, I did the simple Python code that if my L was greater than K, then this is the required answer, and the equilateral triangle is nothing but this time c into c plus 1 by 2. And if the triangle was invalid, then my answer was simple 0. So for each particular test case, I printed the required answer, and this also becomes a valid solution. Now, let me discuss where people could go wrong in this particular problem. So, the only thing where people could go wrong is the observational part, because if people figured out that this particular answer is n into n plus 1 by 2 in the end, then I don't think that any in the complexity part or any syntactical part people can go wrong in. So firstly, it was main to just have a look at the observation that the triangles are following a pattern, and the pattern is coming out to be n into n plus 1 by 2 for each particular l and k. So yeah, if any person was able to figure out that, then it would easy for him to code this particular problem. So I hope you like my video. Please like, share and subscribe to our channel. Thank you.